9.1a is about graphing a quadratic from standard form. Thinking back to last unit, we were using this factored form, y equals a times x minus p times q. Unit 9, we're going to be looking at this form, standard form, y equals a times x squared plus bx plus c. Things that stay the same, a positive a value still opens up, a negative a value still opens down. The larger the a value, the narrower or skinnier our graph is going to be. The smaller our a value, the wider our graph is going to be. Those things stay the same. Now, a couple things change. So things that are new, there's a new way to find the vertex. When we are looking for the vertex, we are going to use this formula. X equals negative b divided by 2a, where b and a come from the standard form. Axis of symmetry, well, that'll still be the same x value as our vertex, so that part doesn't change, just how we find it changes. Our y-intercept is always going to be our c value, again coming from that standard form. And if we look at this, well, we know for our y-intercept x is 0, so when we plug that in, that first term turns to 0, that second term turns to 0, and all we're left with is our c value. So that's how our y-intercept works in standard form. We're going to use the parent function, y equals x squared, to take a shortcut when we are graphing. So the vertex of the parent function is always at the origin, so that point 0, 0 right in the middle of our graph. So for our other points, we're going to use this pattern. So if we plug 1 in, well, 1 squared is 1. If we plug 2 in for x, well, 2 squared is 4. If we plug 3 in for x, well, 3 squared is 9. So if we go over 1 and up 1, that is our first point. Over 2 and up 4 would be our second point other than the vertex. Over 3 and up 9 would be our third point other than the vertex. And since the quadratic has those symmetrical properties, we can reflect these points across the axis of symmetry. Okay, and we have our parabola. So we're going to use this pattern. You always go over 1, up 1, then over 2 and up 4, then over 3 and up 9 from the vertex, whatever the vertex of your current parabola is. Now this will change a little bit when the a value changes, but we will look at an example to demonstrate what happens when that a value changes. All right, so let's graph. So we have y equals x squared minus 2x minus 3. Well, notice that our a value is 1, our b value is negative 2, and our c value is negative 3. Since our a value is positive, it's going to open up. Okay, and then we can find our axis of symmetry using that new formula, x equals negative b divided by 2a. Well, my b value is negative 2, so I'll have a negative 2 divided by 2 times a would be 2 times 1. Well, a negative and a negative cancel each other out. We just get positive 2 over positive 2, so our x value is just 1. Well, if we know that our x value is 1, we know our x value of our vertex, so I'm just going to write that down there for a second here. Then remember our y-intercept, it's just always our c value. So in this case, our y-intercept would be the point 0, negative 3. Now our vertex, remember when you have an x value, you plug it in to find y. So I'm going to plug this in. That'd be 1 squared minus 2 times 1 minus 3. Well, 1 minus 2 minus 3 would be negative 4. So that's our vertex. So we have our vertex on our axis of symmetry. We're going to use that same pattern from our parent function to graph the rest of this. Instead of picking an x value and plugging it in to find y, we're just going to use this shortcut. Well, since a is 1, right, a is 1, nothing's going to change. So we are going to do that exact same pattern, start at our vertex, go over 1 and up 1, go over 2 and up 4, go over 3 and up 9, and then we will reflect those across the axis of symmetry. And this is our parabola. Okay, notice how one of our points ends up being that 0, negative 3, right, which is the same as our y-intercept from our graph. So you can see that the points do match up. It's just instead of plugging those numbers in, we're taking this shortcut. And that is how we are going to graph our quadratics in standard form. Let's look at one more where a is not equal to 1. So for y equals negative half times x squared minus x plus 1, well, a is negative half, b is negative 1, c is positive 1, right? Well, since c is positive 1, we already know our y-intercept. Right? Well, this is negative, so we know it opens down. And then for our axis of symmetry, we're going to plug it into that formula. Negative b divided by 2a. Well, negative b would be negative times negative 1 over 2 times negative half. Well, a negative and a negative make a positive. 2 times negative 1/2 is negative 1. 1 divided by negative 1 is negative 1. So the x value of our vertex is negative 1. I'm going to have you pause the video and find your y value. So we have our vertex and our axis of symmetry. And now we need to figure out, well, how far over and down do we need to go to graph this parabola? Since our a value is no longer 1, it's going to change a little bit. So we're going to start off with these same numbers. You're going to use these same numbers every single time you're graphing one of these quadratics. But this third column, we want to figure out what a times y is, okay? Because whatever a times y is, that will tell us exactly how this other a value, a equals negative 1, changes our parabola. So 4 times negative half is negative 2. 1 times negative half is negative half. So I'm going to fill in my chart. Okay? So now instead of going over 2 or to the left 2 and up 4, I'm going to go over 2 from my vertex and down 2. I'm going to go over 1 from my vertex and down 1/2. Okay, and so that's how our a value changes our parabola. So I'm going to take a second to graph this. So we have over 1, down 1/2, over 2, down 2. And reflect that across the axis of symmetry, and this is our parabola. Connect the dots and we are done. So again, you're always going to start off with these same numbers for your parent function, and then when you multiply our y column by whatever your a value is, that will be how you graph your parabola. Just a couple of reminders. Remember, we have a new formula for finding the axis of symmetry, and just by looking at that c value, you can figure out your y-intercept.